Okay, in this video, I'm going to cover only two problems here that are done a little bit different than what I discussed in class. In the video for spring 2015 for math for teachers, I used the graphing calculator. Now, number 16 and number 33, I'm going to go over the problems the way that I did it in class with you all. And I omitted parts B and part C. Here you have to find the greatest common divisor and the least common multiple of the following. And in this case, in part A was 63 and 14. Alright, we'll start with the greatest common divisor, or GCD. The way I did this in class was to use the prime factorization of 63 and 14. Now for 63, I know it's going to be 7 times 9. I can break that up into 7 times 9. And 7 is a prime number, so we'll circle the 7. And 9 can be broken up into 3 times 3. And 3 is a prime number, so I'll circle that. Now for 14, that can only be broken up into 2 factors that are prime numbers, 7 and 2. 7 is prime and 2 is prime. So that's the prime factorization of 63 and the prime factorization of 14. Now to find the greatest common divisor, we use the common factor that's in both of these numbers the least number of times. In this case, 7 is the common factor because that's a factor that's in both 63 and 14. Now I can't use 3 because 3 is not a factor of 14. And I can't use 2 because 2 is not a factor in 63. So only the greatest common divisor for 63 and 14 would be 7. Okay, that's how we find the greatest common divisor. Now for the least common multiple, now we can still use this right here, the prime factorization of 63 and 14. But the way we find the least common multiple is this. We use each factor the greatest number of times that it occurs in any single factorization. Like the 7 is only used once in a single factorization. In the 14, that 7 is only used once in a single factorization. So we write down the 7. Here we use the 3 twice, because 3 is used as a factor twice in a single factorization. And also we use the 2, because 2 is used as a factor once in a single factorization. So here we're going to multiply 7 times 3 times 3 times 2. When we multiply all that out, you'll get 126. So the least common multiple of 63 and 14 would be 126. Now another way you could have found the least common multiple, of course, would be to list the multiples of 63 and 14. So here you got 63 and then 126. And if I stop at 126, 14 may take a while because I'll have 14, 28, and then 42, 56, 70, 84, 98, 112, and then 126. And you'll see that 126 is the smallest multiple for 63 and 14. So the least common multiple there would be 126. Okay, now the other problem that I did a little bit differently than on the video for spring of 2015 would be number 33. That's finding the balance in the account after 4 years if $1,000 was invested at 9% annual rate and the interest was compounded quarterly. And here you see the compounding period, which is quarterly. The principal is $1,000. Interest rate, annual interest rate is 9%. The length of time is 4 years. We need the interest rate per period, the amount of the interest paid, and the total amount in the account. Okay, so I'm going to show you how that's going to be done. Alright, we need to find out the interest rate per period. Now, the interest rate, of course, that was given to you as 9%, and the problem. Now, if it's compounded quarterly, that means that there are 4 compoundings in a year. So that means we need to take 9%, divide that by 4%. So if we do 9% divided by 4%, that's going to be 2.25% per period. Okay? Now we're already given the number of periods, which is 16. So we know n is going to be 16. And before I go any further, I need to convert 2.25% to a decimal. What you can do is do 2.25, divide that by 100, or move the decimal point 2 places to the left. You'll get 0.0225. That will be the decimal value for the interest rate per period. And n is going to be the number of periods, which is given to you as 16. So, our formula for finding the total amount will be A is equal to P times 1 plus R, and that quantity is to the nth power. Okay? The n is the number of periods, the R is the interest rate per period, and the P is the principal, which is in this case $1,000. So we got A is equal to 1,000 multiplied by 1 plus R as a decimal would be 0.0225. And that quantity to the nth power, n is 16. And then we can type all of this into our calculator. And if you do have the TI-84 or 83 plus calculator, doesn't matter. This will be 1,000. Well, let me clear this calculator out. 1,000, and then left parentheses 1 plus 0.0225, close parentheses, and that's going to be raised to the 16th power. And that will be the total amount in the account. To 2 decimal places, that will be 1427.62. So we're talking about $1,427.62. That's going to be the amount, the total amount, which is going to be going into this box right here. But we want the amount of interest paid as well. Well, if the principal was $1,000, then the interest paid is going to be the total amount minus our principal. So that total amount was this $1,427.62 minus the principal of $1,000. And that will leave us with the interest that was paid, $427.62. $0.62. Okay? So those are the only two problems on that review sheet that I need to clear up and place on this particular video. The other problems are pretty much similar to what I covered in class, so that should help. Now, if you do have any questions, please feel free to email me or call me or stop by my office if you need additional help.